Today's video lesson is on solving algebraic expressions. The first thing you need to know is the difference between an algebraic expression and a numerical expression. A numerical expression just includes numbers and operation signs, whereas an algebraic expression includes at least one variable. A variable is a number or symbol that can stand for one or more numbers. You can see in the two examples, 31 minus x. X is the unknown variable. 5 times y. Y is the unknown variable. Please be aware that this algebraic expression can represent a word problem or a real life problem. For example, there are 31 desks in my room. I would like to know how many empty desks I'll have first period. Well, in order to know that, I'd need to know the value of this variable. That variable could change depending on how many students attend class today. So if 28 students attended class, x would equal 28. Then I could solve this expression and subtract 31 minus 28 to find out that there will be 3 empty desks. Now that there's an equal sign, this is known as an equation. In the situation of 5 times y, perhaps my family wanted to go to a hayride, and it cost $5 per person. The people running the hayride would know how much to charge based on how many people were in line. So if my family with 6 people arrived, y would equal 6. So they would know to multiply 5 times 6 to see it would cost $30 for my family to go on the hayride. So algebraic expressions are a great way to help you to solve word problems, because you can take a word problem, which can sometimes be a burden to a student, and turn it into an expression, which is generally pretty easy to solve. Before we start, though, it's important to know that there are 4 ways to show multiplication using variables. One is you could use the traditional x to show multiplication. But as you probably could tell, using an x to show multiplication is not a good idea, because an x and an a right next to each other could be read as 8 times x times a. And so some people would not be sure whether that meant multiplication or if it was another variable. So it's not encouraged, now that we're using variables, to use x to show multiplication. It's much preferred to use the multiplication dot. Another way, as you've learned before when solving order of operation questions, is you can use parentheses to show multiplication. This would also show 8 times a. Now, the problem with that is it's a lot of work to put those parentheses, and many students confuse the order of operations when parentheses exist in a problem. The best way, in my opinion, as we're moving through and learning algebra instruction, is to use what's known as a coefficient. This number a is a coefficient because it's connected. It's working together with this letter a, and it shows multiplication. So the coefficient 8a means 8 times a, but you save the aggravation of writing in parentheses or the dot. So anytime you see a number directly in front of a letter, it means you multiply them together. Obviously, when you write in the value of a, let's say we knew a is equal to 5, you wouldn't write it as 85. It's now a 8 times 5. So the value of 8a in this situation would be 40. It's important when writing a coefficient that you always write the number first, then the variable. So 8a is good, but not a8. That would not work. And remember, variables are to be written in lowercase always. So 8m is correct, not 8m with a capital M. That's especially important when dealing with the number 5 and the variable s. If you made that uppercase, that sure looks like 55 to me. So be very aware, lowercase variables only, and the number always comes first. There are 2 ways to show division in an expression, using your traditional division symbol, or you could use a fraction bar. So both of these expressions say 8 divided by m, 8 divided by m. Now let's go ahead and recognize that when solving expressions, we want to substitute the known value of the variable and then solve. For the examples we're going to do now, we're going to use a is equal to 5, b is equal to 8, and c equals 12. Now remember, this isn't a code. A doesn't always equal 5, b doesn't always equal 8, and c doesn't always equal 12, just in the examples that we're going to do right now. So in this example, you see the coefficient 2a plus b. The best way to solve this is now to substitute the value for A as a 5. And remember, that's 2 times 5 plus the value for B, which is 8. And remember, we've got to solve following the order of operations. So we'll do 2 times 5 is 10, then add the 8, giving us a value of 18. So 2A plus B equals 18. We have two coefficients here, so 4 times A will be 4 times 5, and 2 times B will be 2 times 8. And again, we want to follow the order of operations. 4 times 5 is 20, and 2 times 8 is 16, and then we can add to get our solution 36. In this case, there's no coefficient, so we're just going to substitute the C for 12 and write 12 minus 9 equals 3. Many students try to do these in their head without writing out the numbers, and although I can understand it, why, since we're first beginning our algebraic expressions, I highly recommend that you rewrite the problems because it's going to be much easier for us to know where your error is, whether it's a simple addition, subtraction, multiplication, or division error, or if it's an error in substituting your value. So I really would like to see the actual numerical expression rewritten before you solve. Another coefficient situation, again, 2 times C would be 2 times 12, and 2 times A would be 2 times 5. And again, we're going to follow the order of operations. 2 times 12 is 24, 2 times 5 is 10, and then we can subtract, and we know 24 minus 10 is 14. And then in this last example, we have both multiplication and division. When you've got the division bar set up, everything on the top needs to be solved together, and everything on the bottom would need to be solved together as if they were in parentheses. So first, we're going to deal with the 2C, which we know means 2 times 12, and then that would be over 8. So we're going to need to solve this before we can actually divide it. And 2 times 12 we know is 24, and 24 divided by 8 we all know is 3. So there you go. I have one word problem we're going to use in this situation, and let's go ahead and take a look at this. The Franklin Institute in Philadelphia, move my camera so you guys can see the whole question. There we go. The Franklin Institute in Philadelphia charges $16.50 for adults and $12 for children. How much would it cost for 2 adults and 4 children to visit? Well, in this situation, we know that we're having 2 adults, and 2 is the variable you're going to use in this expression. You really would write this out as 1650 A plus $12 C. And the A would represent the number of adults, and the 12 would represent, or the C would represent the number of children. So we're going to go ahead and multiply 1650 times 2, because there are 2 adults, and then $12 times 4. You'll note in this situation, we used decimal numbers as our coefficient. You can actually use decimals, fractions, mixed numbers. All of those can be used in a coefficient. So now we've got this set up. The 1650 times 2, we're not going to do in our head. We're going to show our work over here, following our standard procedure we learned for multiplying decimals. Okay, and the cost of the adults is $33. And since 12 times 4 is a basic fact, I think we can all agree that that answer is 48. And now we're going to line up our decimal points and solve $33 plus $48. And it will cost $81 to take a family of 2 adults and 4 children to the Franklin Institute in Philadelphia. Thank you for sticking around till the end. Good luck using those coefficients and variables.